Hi, Goody. I am going to discuss about circle, semicircle, ring. Circle is like that. Semicircle is the half of the circle, and it likes that. And ring is the hollow circle. It is like that. A circle is a set of all points in a plane that are equidistant from a fixed point. The fixed point is known as center of the circle, and the equidistance is known as the radius. In this figure, O is the radius, whereas the point O is the center of this circle. Here, AB is the diameter of this circle. AB is the largest chord that passes through the center point O. There is a relation in between diameter and radius. This is d equals to 2r, that is r equals to d by 2. The circumference is the boundary of the circle. In triangles, polygons, we call this term as perimeter, but for circle, this is known as circumference. Circumference of a circle is equal to 2 pi r, where pi is a fixed valued number that is equals to 22 by 7. Now, a line segment AB intersects the circle at points C and D respectively, and this line segment AB is known as secant. So, when a line segment intersect a circle in two distinct points, then this is known as the secant of the circle. When a line segment touches a circle at a point, then this line segment is known as tangent. Here AB is the tangent, and which touches the circle at point O. The line segment within the circle touches two points of the circumference, two different points of circumference, then this is known as the chord. Here, as you see, AB is a chord of this circle. There are infinite number of chords, but which chord passes through the center, this particular chord is named as the diameter. It has the greatest length among the chords. Okay. The chord diameter passes through center. Already I told. A part of a circumference is known as the arc of the circle. Here, AB arc is ACB. AB. Arc AB is denoted by like that, and it is to be read as AB arc. Okay. If we join the two endpoints of the arc A and B to the center point of the circle O, then we will get OA and OB, and they are the radii of the circle, and the measure of this radii are equal to R. In this figure, you see the diagram of a sector of the circle. AOB is the sector. It is the bounded area by the two radii and the arc AB, and is known as sector. ACB ACBA is the segment of the circle. Segment of the circle. So, a segment of a circle is bounded by an arc and a chord. Here, the arc is ACB and the chord is AB. You have to understand the difference between sector and segment very clearly. You should not have any confusion in these two terms. Sector is associated with the center, sector and center, right? But segment is not associated with center. Segment is associated with the arc and chord only. So, you have to remember the difference between two terms. You may remind like this. Sector, the last letter is R. Sector made of by radius, two radius and an arc. So, sector is associated with radius, whereas segment is not associated with the radius, but it associates with the chord and arc. Okay. Now I hope that you will be able to distinguish between sector and segment, and you will not be done any mistake to recognize sector and segment. Now I am telling you about the central angle and the inscribed angle. There are two terms, central angle and inscribed angle, closely two terms. You have to distinguish. Central angle. Central angle associated with the center of the circle, but inscribed angle is not associated with the center of the circle, but it is associated with the points of circumference. Points on circumference. So, what is a central angle. If a chord, if a chord AB makes an angle at at the point at the center point O, then this angle is known as central angle. Here AOB is a central angle. If two chords intersects or meet on the circumference of a circle, then these two are these two chords makes an angle which is known as inscribed angle. Here AB and CB meet on the circumference of the circle at point P and makes an angle ABC. Then ABC is an inscribed angle, right? Here is a relation in between inscribed angle and central angle. Inscribed angle is equal to the half of the central angle. In other hand, or in other words, central angle is the double of the inscribed angle. According to the figure, the central angle BAC equals to the inscribed angle BAC equals to half of the central angle BOC. In other words, the central angle BOC equals to double of the inscribed angle BAC. What do we mean by concentric circles? Concentric circles are those circles which have a common center but different radius. Here, O is the common center of these circles, say circle 1, circle 2, circle 3 and circle 4. So, they are the concentric circle because their common center is O and the radius of circle 1 is R1, whereas radius of circle 2 is R2 and the radius of circle 3 is the R3 and the radius of circle 4 is R4. So circle 1, circle 2, circle 3 and circle 4 are the concentric circles. What I have told that pi is a constant and it is the ratio of circumference by diameter equals to 22/7. It is fixed for all time. Apollonian circles, orthogonal circles are not to describe here because it is not so much important in our target syllabus. Now come to the point area of circle. Area of circle equal to pi r square, where r is the radius, pi r square. The length of the circumference of a circle already I told, that is 2 pi r. Now here we see the arc length S. How do we calculate the arc length S? Here is a formula S equal to arc theta, where theta is the center angle in radian. We know that the circumference, the whole circumference length is 2 pi r, and it makes an angle at center is 360 degree or a complete angle. So 360 degree makes by the length of circumference 2 pi r. Similarly, 1 degree can be made by 2 pi r divided by 360 degree of length of the. So theta degree is made by theta by 360 degree into 2 pi r length of r. But if we convert this figure into radian, then what will we get? We have to put 360 degree. We have to put 2 pi in place of 360 degree. Then the degree will be converted into radian. So in radian, we will get theta. So an arc makes an angle theta at the center of a circle, then the length of this arc will be theta r. Okay. So if theta equal to 60 degree, then what will be the length of the arc? The length of the arc is equals to 60 by 360 degree into 2 pi r equals to pi r by 3. Okay. In radian, 60 degree equals to pi by 3. So the length of the arc will be pi r by 3. Okay. Now area of the sector. In this figure, AOB is a sector. What will be the area of this sector? The whole circle, the area of the whole circle is equal to pi r square. So the full circle area makes an angle at the center is equal to 2 pi radian. So 2 pi radian makes pi r square area of sector. Therefore, using unitary method, we can get 1 radian equal to r square by 2 area of sector, and theta radian equal to 1 by 2 into r square theta area of the sector. So sector area equals to half into r square theta. Then how do we calculate the segment area? Segment area equals to half into r square into theta minus sine theta. Here is the diagram of a segment. This crossed area, this shaded area is the segment area. The segment area equals to sector area AOB, A sector area minus area of this triangle OAB. This is equals to the sector area. We know that equals to half r square theta, and the area of this triangle AOB equals to half r square sine theta. So the segment area equals to half r square theta minus sine theta. You may have query how I put half r square sine theta in place of the area of triangle AOB. Here is the clarification. AOB, this triangle AOB, this triangle OAB is drawn as here ABC. Here OA equal to R and OB equal to R. Here AB and AC equals to R. So these two triangles are similar, and this angle theta and BAC angle equals to theta. As the sides of triangle AB equals to AC, therefore the triangle is an isosceles triangle, and we know that if we draw a perpendicular from the vertex A of this triangle to the base of BC, then AD bisects BC. How? Once again I am repeating. For these two triangles ABD and ACD, these two are right angle. These two angles are equal. These base two angles are equal, and AD is common. Therefore, these two triangles are congruent to each other. Therefore, this angle equals to this angle. If the total angle is theta, then each angle will be equal to theta by 2. So, VD equal to DC. Now, area of triangle ADC equals to half into AD into DC. Here AD is the height and DC is the base. Equals to half into AD means R cos theta by 2 and DC means R sin theta by 2. If you not understand how this line is written, then you have to take reference to my previous video on trigonometry. Okay, and as well as my previous video, the heart of the geometric shapes, that is triangle treasures. Now, this is equal to half r square cos theta by 2 into sin theta by 2. Therefore, the area of triangle ABC equals to area of triangle ADC plus area of triangle ADB. Since these two triangles are equal in area, so this is equal to 2 into area of triangle ADC. We already find out the area of triangle ADC and put it here and get 2 into half into r square cos theta by 2 into sin theta by 2. It can be written like this: half into r square into 2 sin theta by 2 into cos theta by 2 and equals to half into r square sin theta. Since we know the formula, sin 2 theta equals to 2 sin theta cos theta, right? So here sin theta equals to 2 sin theta by 2 into cos theta by 2, right? So the area of ABC equals to half into r square sin theta. Therefore, the segment area equals to half into r square theta minus sin theta, right? Now, perimeter of semicircle. Semicircle is the half of circle. Semicircle is the half of circle. So, you are ready to reply. The perimeter of semicircle will be pi r because the perimeter of circle is 2 pi r and semicircle is the half of the circle. So the perimeter of semicircle will be pi r. But if you give this answer, then you have done a mistake because of in perimeter of semicircle the length of diameter is included here. Therefore, the perimeter of semicircle equal to pi r plus 2r equals to r into pi plus 2. You should have to sincere in this point to avoid the same type of mistake. What will be the area of semicircle? It is the half of the area of circle. It is true. The area of the circle is pi r square. The area of circle is pi r square, and pi r square divided by 2 is equal to the area of semicircle. Okay. Now we come to ring. The diagram of ring will be like that. The shaded area is ring. The ring has an inner radius and an outer radius. The inner radius let be smaller and the outer radius let be capital R respectively. Then the outer perimeter of this ring equals to 2 pi capital R and the inner perimeter or circumference of inner side of the ring is equal to 2 pi small r. So the perimeter of a ring equals to 2 pi capital R plus 2 pi small r. Perimeter is used, the term perimeter is used in triangles, polygons, etc. But for circle, in place of perimeter, circumference is used. So the inner circumference is 2 pi smaller and the outer circumference is 2 pi capital R. Therefore, the perimeter of the ring will be 2 pi capital R plus 2 pi small r. If we take common 2 pi from these two terms, then we will get 2 pi into r plus r. Right? This is the perimeter of a ring. And the area of a ring, the outer circle area will be pi capital R square, whereas the inner circle area is pi small r square. This is the inner side is the hollow. So this area to be subtracted from the total area, and we will get pi capital R square minus pi small r square. It is the area of a ring. If we take common pi, then area of a ring equals to pi r square minus r square. You know that the formula, the algebraic identity, r square minus r square equals to r plus r into r minus r. Okay. So, till now, we have discussed the term circle, semicircle, ring, and we have seen the diagram of circle, semicircle, and ring, and we have discussed some terminologies associated with circle, that is their center, radius, diameter, circumference, chord, secant, tangent, arc, sector, segment, central angle, inscribed angle, concentric circles, phi, and also relation between inscribed angle and central angle, the formula to find out circumference, and the relation in between diameter and radius, and the value of pi. Then we have to know the area of circle already covered, and the arc length is equal to arc theta. We covered sector area equals to half r square theta, and segment area equals to half r square theta minus sine theta, as well as we come to know about the perimeter of semicircle, area of semicircle, perimeter of a ring, and lastly area of a ring. Thank you very much. Before completing this video, I am informing you that Finsplate is launching a short-term course on placement training for RRB SSC, PSC, and other competitive exams aspirants, interested candidate may contact with Finsbury through mail or phone number or phones. This will be very helpful for them. Once again, I am giving my heartiest thanks to all viewers. Okay, thank you.